Most of the rules we've looked at in previous videos about simplifying problems with rational exponents and radicals, we can use even when variables are involved. So let me give you a few tricks for simplifying some of these expressions. So our first couple examples, notice they're really the same thing. They don't look anything at all alike, but what I'm noticing, one of them is a cube root and one of them has a 1/3 power. Those are exactly the same. I could rearrange one of them to look like the other expression if I wanted to. So I'll show you two different methods for simplifying these. If you like one more than the other, remember you could change one to look like the other. So either method should be able to work for these first two examples. So method one works like this. I'm dealing with the cube root of 64. I'm going to ignore the variable piece for right now. So in our previous video, we simplified expressions by doing a factor tree. So let's do that again. I'm going to break 64 down into 8s and 8s. You can break down 64 other ways, but I'm going to do 8 and 8. The reason I like 8 is because I can simplify that or factor that into 2 times 2 times 2. I like to do it that way. If that bothers you, then you can simplify it like we normally do. And then 2 and 2 and 2. So what I'm looking for are sets of 3. Well, in this case, I can say I have a set of 3 right there, and I have a set of 3 right there. 3 2s is what I mean. So each of those sets gets to come out, meaning out front of this radical, I've got a 2 times a 2 and nothing was left over. Everything got out of the radical. Next up, let's do the variable part of this. Well, y to the 6th means y times itself 6 times. So go ahead and write out 6 y's. Y. Like a 5-year-old would ask. And once again, I'm looking for sets of 3. So I can see, well, there's a set of 3 right there, and there's a set of 3 right there. So what I can take out is I can take out a y, that's a set of y's, and then take out another one, and there's nothing left over. Once I simplify that, 2 times y gets me just 4y squared as my simplified expression. Well, some of you may have noticed something we could have taken a little bit more of a shortcut. When I had scribbled out that first part and said, what's the cube root of 64? Some of you may have recognized right away that the cube root of 64 is just 4. So we could have done that and saved a little bit of time. Some of you may also notice some things about the exponents, which we'll talk about in the example below this. So here's the other way to work with it. Suppose you didn't like that method so much. You could have rewritten that cubed root so it was a 1/3 power instead. So in this case, here's another way to simplify. Because this is a single term, there's no plus or minus signs in there, I'm allowed to distribute my exponent to each piece in here. Let's start from the back of this and work towards the front. In the back, I have a power raised to a power. Well, all along the rule has been to multiply. So let's continue it. The rules haven't changed. 12 times 1/3 is 4, so I get q to the 4th power. Next up I have p. 3 times 1/3 gets me a 1, so I get p to the 1st power. And then be careful about what's in front. That 27 is not an exponent, so don't you dare multiply 27 times 1/3. That's still just 27 raised to the 1/3 power. Well, what I want to try to do is simplify that, and if you remember, raising something to the 1/3 power is the same as doing a cube root, and 27 is a perfect cube, so I can simplify this one step further by saying just 3, that's the cube root of 27, and then pq to the 4th power. If you like that method better, feel free to try that on the first problem. Taking a look at a fraction inside of a radical, as we've done with square roots, let's simplify that into split that into two separate problems. So the numerator I can rewrite as the 4th root of m to the 4th, and the denominator I'll rewrite as the 4th root of n to the 8th. Well, let me make that n a little bit better, n to the 8th, there we go. Well, like we did on top, let's kind of think about what this means. M to the 4th power means I have 4 m's being multiplied together. Well, this time I need a set of 4 to get out, and look, I have a set of 4. So I'm going to have one single m on the outside. Nothing was left over to be on the inside. On the bottom, I have n to the 8th. Well, maybe try to do this part in your head. Imagine 8 n's all being multiplied together in a row, and I want to see how many sets of 4 I can get out of that. Well, I'd be able to circle 2 sets of them, meaning n squared is what I can take out, and nothing was left over, so they make a clean sweep, and they're out. So m over n squared would be my simplified expression. We talked about a shortcut. Some of you may have noticed if you divided your exponent by your roots, 4 divided by 4 gets you 1. 8 divided by 4 gets you 2. That shortcut will absolutely work, so feel free to use that if you'd like to. If it doesn't divide evenly, though, you're in trouble. One last one to take a look at. Again, just some different rules to try when you're simplifying a few of these problems that involve variables as well as your rational exponents. Your coefficients, 14 and 2, they behave like normal. Simplify them like you'd always simplify 14 over 2 as just 7 over 1. Next up, let's try to simplify our x's. I have an x on top and bottom, so I'm going to use the normal rule we've always used when dividing exponents, and that is to subtract. Always do the top exponent minus the bottom, and write your answer in the top of the fraction. If it comes up negative, then you'll have to move it. 1 minus 3/4, though, is fine. That comes up as 1/4. That's totally fine to have. Notice your y is the only y piece in here, so that is fine the way it is. So y to the 1/3 power. And last up, we have that z. I never want to work with negative exponents, so let's move that up to the top. Things are free to move individually. So I can move that up to make it z to the positive 6th power. In this case, if I want to throw the 1 down there, I can. Otherwise, I would just go ahead and say, there's my simplified expression.